All right, guys. I went ahead and changed the title of this to be more fitting of what we covered yesterday. I just basic transformation of functions. So we did the warm up. Just to quickly review these, translation 3 units to the right of x plus 6, we got x plus 3. Translation 1 unit left of this function, minus 2, so these end up doing the opposite of what you might expect at first. And then the number 3, the translation 1 unit down, was applied to always the outside constant term. If this guy did not have an outside constant, you could imagine it says plus 0, and you could just then end up writing the absolute value of this minus 1, just in case there's nothing actually written out here. It's absolutely done to the outside constant term. Then we went on to demonstrating how y ends up being minus 3 for translation to the right, which is always the one that's connected with the x. Then we discussed absolute value. I just demonstrated here that g of x is equal to absolute value of x minus 3, which is just taking the absolute value function of f of x and just going down 3 units. And this is where we left off. Let's see. Where we had something in this form here, quadratic in this form, and this here, this is known as vertex form. The vertex form, and the vertex is going to lie at HK. That's where it is. So if we had something that was in this form, you'll want to start out plotting the vertex, which is going to be the point HK. So now let's look at how, if we just had the parent function, what this guy would look like compared to this. And we kind of felt like we kind of trying to rush this the last few minutes. So let's start off here. Pick back up here. If we have, if h is greater than 0, so we're just talking about this here. This is just basically saying that this guy is the translation left or right. And be careful that it's x minus h. That's why it says this. When if h is greater than 0, it's the translation h units to the right. And then if h is less than 0, translation h units to the left. Then they go on to talk about k, which is on the outside. H and K, I think, are fairly straightforward. Those are just the translations left, right, up, and down. And then the new concept, might feel like a newer concept, is the A out in the front. So in vertex form, A out in the front, we're just talking about vertical stretching. So this is implying, don't worry about the sign of A for now when thinking about stretching, just the absolute value of it. And so they're saying that if the absolute value of A is greater than 1, we're going to end up stretching this. It's going to look stretched. So for example, let's say you go ahead and you plot your vertex. And based on the parent function, if this point here used to have some output of, say, used to be, say, 4 units up compared to the vertex, Now it's going to be, if A were 3, it would be 12 units up vertically from the vertex. And we'll see this graphically, but I'm just going to talk about this while we're on the slide. We'll do some examples. And then here it's just saying that if the absolute value of A is fractional between 0 and 1, that's a vertical compression, and they also use the word shrink this in this way by a factor of 1 over A. I've seen this written 2 different ways right here, where I've seen it written as compression by a factor of just absolute value of A, and also seen it written as compression by a factor of absolute value of 1 over A. Depending on how you want to think about it, just know that when A is fractional, we're talking about compression. But when A is greater than, the absolute value of A is greater than 1, we're talking about stretching. And then I went and showed some examples of where you would have, say the parent function is the blue, f of x equals x squared. G of x, because the A is 3, you can see how this blue has been stretched. And then h of x, when the A was fractional, you can see how it was vertically shrunk or compressed compared to the parent function f of x equals x squared. And then we start talking about the reflecting. So now, depending on whether the value of A is positive or negative, if A is We're just picking back up where we left off yesterday. If you were here yesterday? Yes. Okay. So, if A is negative, we're going to be talking about, it's going to be a reflection about the x-axis. You could think of this as, this brown here, as negative g of x. In the sense that it should make sense that whatever was the output for g of x, well, the outputs for this guy are going to be whatever the opposite of what the outputs for g of x. So if this point here is, let's say you have 1, 3, well, if you input 1 into this guy, you would end up getting negative 3. So just showing you what happens when you stick a negative in front of the entire function, it just reflects it about the x-axis. Anyone need more time on this? This is kind of where we left off. Okay. And if you know, any point you need to, of course, you can look at these on your own time. Let's see here. I think I can do that. Yeah. So, working with a partner, match each quadratic function with its graph, explain your reasoning, then use a graphing calculator to verify that your answer is correct. So, I want you guys to work with a partner and see if you can match choices A through F with these 6 choices here. And then at the end, we'll go ahead and we can check them graphically. But see if you guys can figure out which is which and discuss it with your partner and see what you come up with. And then we'll discuss it. Alright, so the vertex form of this guy is written here. Where if it's written in this form, then the vertex is HK. So, looking at choice A here, right in here, what would the vertex of choice A be?
Can't even see half the other ones. It's well.
I'm asking a question just about this right here.
Yeah, and we can't see D, E, or F because it's cut off.
What would the vertex of this be? I don't know if this makes it more clear what I'm trying to emphasize, that I don't care about this graph right now. I'm trying to make a very simple point. What would the vertex of this be? Okay, so when it's in vertex form, if it's in this form, the vertex is HK. Is anyone confused about that?
No.
Okay. So, what is the vertex of choice A?
2 squared.
2 what? 2 squared. Okay, I still don't think we're quite understanding here
But
then.
then that's what C squared.
2 squared.
Negative 2.
I'm talking about a point on a plane, which has X and Y coordinates, or here, H and K.
X and T.
Okay, so X minus H squared plus K, we're close.
See, you're showing us one that has like the plus, like,
With the K at the end.
yeah, you're
Okay.
showing that, so we can't really fully understand the graph spot. Now, maybe for D or something we could, but I don't know.
Yeah.
Okay,
Because the example you're showing isn't matching the one that you're
it's not matching?
It's
It's not matching? Okay.
Yeah.
I tried not being here, bro.
I know, that's what I'm saying. That. Oh, now it's going to be 2-0.
Thank you. It's 2-0. Yeah. Okay. What is the vertex of choice B? How intuitive was that?
Oh, very.
Okay. What's the vertex of choice B?
2.
2 and 2, very good. What's the vertex of choice C?
We can't see.
2 and 0.
Oh,
No, 2
two.
and negative 2.
2 and
Why are they all
negative 2?
2 and 0?
I disagree on choice C being 2, negative 2 for the vertex.
Why not?
Why is that? Because
Why do you
Negative
disagree?
2 and
the reason is because the vertex form is A x minus H squared plus K.
negative.
So you want flip flop it? Make that a negative 2 and then 2?
You want to trick away?
Well, there's a negative register.
No, I'm fine. I'm fine with that. What A can be whatever, as long as it's the constant, that's fine out the front. I do have this binomial contain x squared, that's fine. But the form, the vertex form is A x minus H squared plus K. Thank you, very good.
Yeah.
Yes. Isn't x plus 2 the exact same thing as x minus negative 2? Okay. Okay, and what will be the vertex of choice D?
2.
What is that?
Negative 2.
What is this 2? What is people keep saying squared?
Okay,
No, we're making this way more, no, so let's go back again. Let's go back again. So when it's in vertex form, as it's written here, you guys are making this more difficult than it is, I promise you. When it's written like this, the vertex is simply HK. That's it. That's it. So what is the vertex of choice D?
2 negative 2.
2, negative 2. Yeah. And the vertex of choice E? What's that?
2,
2, 0. Good. And the vertex of choice F?
Negative 2. Oh, 2.
Negative 2, 2. Okay. We got a lot of 2's going on here, okay?
That's what I said.
But, so we can kind of eliminate some things because they're not all exactly the same thing. It looks like the ones that have the same vertex are choices A, and what also have the same vertex as choice A? Mm-hmm. B? It is E. Yes, yes. It is E. For those of you that said E, it's E. Okay. So now if we start to look at our choices here, of these 6 choices, which are the ones that only have a vertex at 2, 0? This A has a vertex at 2, 0.
How are we, B and B?
It is B. This looks like 2, 0 to me.
Which one are we doing?
Which one are we doing? Okay. So what I'm saying is, this is what I'm doing. Because I have 6 choices, I'm trying to go through and like kind of eliminate some choices here. So choices A and E, raise your hand if you don't understand that the vertex is 2, 0. That part's solid. Are those the only 2 of these 6 that have a vertex of 2, 0?
Yeah.
Okay. So what I'm doing is I'm just going to go ahead and look at graphically the only choices that have a vertex at 2, 0. B and D, correct. 2, 0 vertex, 2, 0. What is blatantly, obviously different about B and D graphically? Without even looking, yeah. Wait, what? One's what? Yeah, that's what I want to hear. One's concave up and one is concave down. Because concavity is going to be consistent no matter where it is. So let's go over the details, okay? So because I'm going to provide, I think, a lot of clarity because it feels like there's so much information about quadratics, more than you ever wanted to know or ever wanted to learn. Probably feel that way. Okay? Look at choice E. Choice E is negative from negative infinity up until what looks like to be about -1, -2, about -3 1/3 or so. Then the function is positive from about -3 1/3 till about -1/2. Then the function is negative from about x equals -1/2 to going on to infinity. So we talk about the value of function, that, whether it being positive or negative, well, it depends on the parts of it that lie above the x-axis and the parts that lie below the x-axis. That being said, where is choice A? Where is the value of that function positive?
Oh, nowhere.
Nowhere. Thank you. The choice A, the value of this function is negative the whole way across the entire domain. It is negative. And choice B, is it negative anywhere? Correct. It does have a 0 though, but besides that 0, the function is positive for the entire domain. You need help with something? You went like this.
Oh, no. Yeah, we're good.
Okay. Okay. Does that so even though, let's go back to choice E. Choice E is choice
3 1/3.
Choice E is negative from here to here, positive from here to here, and negative here. But choice E is concave down the whole time. For the whole domain. So when we talk about the value of the function, that's different than talking about the concavity of it. They're not necessarily the same thing. Does that make sense? Okay. Sort of? Okay. So let's go back to process of elimination here because I gotta match things. And this kind of goes along with your strategy-wise ACT, SAT when you have to eliminate choices. So I'm looking at A and E. We determined that it's definitely B and D. Now, which goes with which? I hate the fact that they just decided to use letters and not like numbers and letters. So let's see how this works out. So this choice A goes with what down here?
Give me a second. It goes with D.
It goes with D, yes, and why?
Because now you said that the vertex is 2, 0, and that one's 2,
Yeah, but this one also has a vertex that's 2,
0.
0.
That one's negative.
What's negative?
It's concave down. Oh, my. Well, no, I'm talking about the equation, bro.
Oh, there.
Dang.
Oh, okay, so the A is negative.
Yeah.
Yes. The A here, yes. This A is, what is the value of A? For
-1.
-1, good. And because it's negative, it has to be concave down. So we know that this choice A goes with this guy here.
Most likely going to fit it.
And then we already determined, okay, E must then go with B, but it does make sense that because this is positive, A is positive, must be concave up. So here, this must be concave up.
I didn't see this one.
Okay, so A and E are taken care of. Now, we're talking about things that we've been talking about with stretching and all that. Is choice A, compared to the parent function, the basic f of x equals x squared, has choice A been stretched or shrunk at all? Let's go back to our notes. It says this. If the absolute value of A is greater than 1, there's a vertical stretch. If the absolute value of A is between 0 and 1, there's a vertical compression or shrinking.
Now, I want to go back. I want to see the equation just a little bit.
Yeah, so let's go back.
Oh, wait.
So A is -1 for choice for this choice A. A is -1.
It's shrinking.
If the absolute value of A is greater than 1, not greater than or equal to 1, but just greater than 1, there's a stretch. If the absolute value of A is between 0 and 1, not inclusive of 0 or 1, it's a vertical compression or shrinking.
So it doesn't stretch or shrink?
That's correct.
Wow.
Good job. There's no stretching. Good job. There's no stretching or compression going on here because what is the absolute value of -1? 1. Yeah. But the next thing that we're going into is when A is positive or negative, which you guys already have an idea because we've already discussed concavity. When A was negative, it's this. When A is positive, it's this.
Mm-hmm.
But another way to describe that is it's called a reflection in the x-axis.
Oh.
So if this were a positive one, it would simply be the parent function with a vertex of 2, 0. But because there's that negative, it's like, okay, reflection in the x-axis. Any questions so far on looking at choices A and looking at choices, we'll just say looking at choice A? Information about it, you guys want to know more information about it or anything that's not clear? Okay, so now let's look at choice E. What is A? What is the A I'm talking about A, the A coefficient here?
2.
It is 2. And so, based on these notes here, what's that? You say
It's a vertical
I have 5 minutes?
No, and you have to like find the
Well, you don't
the
get
2,
the,
right?
Thanks for the heads up. I think it made perfect sense when I heard you saying we had 5 minutes.
No, I didn't. I said we have to match it with 2.
Oh, I heard someone saying we have 5 minutes. That's what I heard. Maybe
Usually when I get
that works out perfectly because we do.
No, I'm not speaking that.
Okay.
So it's a vertical stretch.
It would be a vertical stretch because the absolute value of 2 is 2 and that's greater than 1, so this would be a vertical stretch.
Yes.
Good job.
So where would it be? Would it be E?
This is a vertical stretch going on here.
So equation E will match.
Oh, why did I write that there? Sorry.
It would go with B, right?
Yeah, but I have it pointed to it, yeah.
Okay.
Yeah.
Oh, I see what you're doing.
Alright. Vertical stretch. Sorry about that. Vertical stretch by a factor of 2 compared to the parent function. Because when I'm talking about compared to the parent function, or the parent function, what is the parent function?
Oh, I got this. F of x equals x squared.
Yep. Thank you. Just the basic guy. The parent function is just the basic guy. F of x equals x squared.
What'd you put?
There's too much side talk going on, guys. It's all coming from over there. All from nothing, no issues over here. It's all coming from over there.
More than one. You over to x? Yeah.
Agree.
Doesn't give you the right to get off on some tangents here. I do appreciate the interactive though, yeah. So anyway, so that's choices A and choices E. Okay, so now, what would be the vertex of, let's say, we've taken care of choices A and choices E. What would be the vertex of choice B?
1, 2.
Negative 2 and 2.
2.
So let me ask this side of the class. What would be the vertex of choice B?
Plus 2.
I have plus 2, positive 2, positive 2, positive 2, 0. Anyone else? What do you think the vertex is of this choice B here? 2 and 2? Okay. No idea? No idea, really? None.
Oh my.
Do I come back over here?
This here makes no sense. What is it form? No? Okay. Yes? What do you think? 2 2 is correct. Yes, 2 2 is correct. Good job.
That's still right.
Was that? Yeah, you're right. Yes. Yes, 2 is positive. Yeah. So this would have a vertex of 2 2.
Wait, why would be 2 2 instead of negative 2 and 2? Why is that?
Oh, now Andy wants to.
Why is the vertex 2 2?
Yeah. Not negative 2 and 2.
Because of this.
Okay.
It's x minus h. Is the
Okay.
form.
I thought
Not x plus h.
I thought it was X.
No.
You didn't know that.